Tell me, from looking at my Notre Dame, what's happening today? Homework quiz. Okay, it's been up there for over a week. Maybe I didn't mention it last class, but it's been there, right? You should be looking, right? They don't have to be announced. But even though I pseudo-announced this one by putting it on there, right? So what is this quiz going to be over?
First and second section.
Yeah, worksheets 1 and 2, right? The only 2 assignments we've had so far. You want to take some questions from those things before we get started? Let's start on worksheet 1, so that we're not jumping back and forth and confusing anybody. Who has a worksheet 1 question? Miriam.
Okay. Can we do a tangent one and an inverse one? Like any inverse one?
When you say inverse, what do you mean?
Like a cotangent.
Okay, so you mean reciprocal then?
Yeah.
Okay. Because inverse tangent and cotangent don't mean the same thing.
Oh. Okay.
Okay. All right, so let's say, how about we do 11 and, what's another good, I guess 12 maybe. How's that? Okay. So let's start with 11. First thing we do is we look at our interval that we have to solve over. And then we go to our unit circle and try to figure out what quadrants we should be looking in. What quadrants are covered by angles that are between 3 pi and 4 pi. So go to my unit circle. And I'm just going to count around. How much is one quadrant? Half a pi, right? So 0. Now we're at half a pi. Add another half, we're at a whole pi. And we're at 1.5, 2, 2.5, 3, that's the start of our interval. 3.5, 4. So what quadrants did we cover? 3 and 4.
How do you why would you say 3 and 4 if you're ending in 4? Like, how do you know when to
Because I started 3 pi here, so any angle
okay.
that you could possibly draw until you get to 4 pi
Yes, okay, got it.
are covering all the angles in quadrants 3 and 4, right? When I say angles, I mean the terminal side lies in quadrant 3 or 4, but I suspect that wasn't what the confusion was. Okay. So now we need to figure out, okay, I know I'm only looking in quadrants 3 and 4. What do I need to be looking for? So this is a tangent problem. On the unit circle, how do we find tangent? Iden.
Y over X.
Y over X. So we know y over x is equal to root 3 over 3. So we might suspect, okay, well, I'm just going to look for the place where the y coordinate is square root of 3 and the x coordinate is positive 3. Let's go look. Oh no, look at those x coordinates. None of them have a positive 3 in it. Well, that can't be right. There must be a little bit more to it. So let's go back and take a look at what else maybe we can do with this. So here's going to be the trick. That square root 3 over 3, I see that and I go, oh, I can reduce that. This is the way that I'm going to think about it in order to see that there's reducing to do. Regular 3 is the same thing as the square root of 3 squared. By doing that, I can now reduce a square root of 3 from the top and bottom. So I can really think about this as 1 over the square root of 3. Okay, Mr. Kulik, now I'm going to look for an x that's a square root of 3 and a y that's a 1. So let's go back and look. So I don't see any place where I have an x coordinate that's just a square root of 3 and a y coordinate that's just a 1. But I do see places where the numerator for the x coordinate is a square root of 3 and the numerator for the y coordinate is a 1. And if I look in both of those points, or both of those coordinates, the denominator is the same. It's 2, right? So what I'm going to do then is say, okay, let's go back to what I had. I'll multiply the top and bottom of that fraction by 1/2. So I can say, okay, x has to be the coordinate square root 3 over 2. Y has to be the coordinate 1/2. Feel good so far? All right. Now I'm going to go back to my unit circle, look in quadrants 3 and 4, and find this sucker, right? All right, let's go look. So, oh, that's close, but they're both negative, right? And, oh, I have one positive, one negative. But I don't see one where they're both positive. Okay, let's go back and look. See, there's got to be some other little thing going on here. So let's think about this. So when I did y divided by x, I get a positive result, right? But what other two things could I divide to still get a positive? If y and x are both negative, negative divided by negative gives me positive, right? Iden.
So I have a question. For tangent, it's quadrant 1 and quadrant 4. You checked 3 and 4. Why?
So what you're doing isn't wrong. We're just not using that all silly turtles crawl piece with this. You could do that and eliminate it down into quadrant 4, but it still doesn't give you the signs the way that you need them to be.
But in quadrant 1, there's 1/2 the square root of 3 over 2.
But quadrant 1 is never going to be between 3 pi and 4 pi. Right?
Okay.
So I know my answer has to be in between those two angles. Nothing in quadrant 1 will ever be in between those two angles. Does that feel okay?
Yeah.
Okay. So now it's like, aha, this one we saw, right? So let's go back and look. There it is right there. So my answer should be 7 pi over 6, right? Almost. Because before I say I'm done, I need to check to see if my answer here lies inside of that interval. So 7 over 6 is 1 1/6, right? Is 1 1/6 in between 3 and 4? No. Did we make a mistake? No. What do we still need to do? We'll just find an angle that's coterminal to 7 pi over 6. Is 7 pi over 6 too big or too small? Too small, right? 1 1/6 is less than 3, which is the bottom of our range. So what should I do to make it bigger, but still keep the tangent equal to root 3 over 3? Add 2 pi. So 1 1/6 plus 2 is 3 1/6, correct?
Yeah.
Which is definitely between 3 and 4. So this will give me the answer I want. To add these fractions, what do I have to have? A common denominator. What would that common denominator be? 6. So when I add 7 pi and 12 pi, I get 19 pi, and the denominator stays 6. That one is our answer. This was like the worstest of the worst case scenarios. Okay? So like all the little bells and whistles and tricks and things had to be pulled out on this one. This is like as bad as it can get. For worksheet 1. This is probably the worst one on worksheet 1. Maya?
Okay, question. But is the 2 pi that you like add, is that like just a thing you know to do, or then?
So we talked about in chapter 2 an idea called coterminal angles. Those are two angles with different measure, but their terminal sides are in the exact same location. You can find an angle that's coterminal to any angle by either adding or subtracting 2 pi, or if you're in degrees, you'd add or subtract 360.
Oh.
Okay, so that's why we knew to do that. So that's our answer. It was just not in the right place. We need to find an equivalent answer that was bigger. We do that just by adding 2 pi until it's big enough, right? If it was still too small after adding it once, I would just do it again and again and again and again until it fit into the range I was looking for. Mora.
Can you do like one more, but like a normal one? Like, that's like a sign. Yeah, like less challenging.
Well, I think the next one is a tad easier, even though it's not a sine or a cosine one. So I'm going to start the same way. I'm going to figure out what quadrants I need to be looking at. So I'm going to go back to my unit circle, and we have some counting to do. So both of the angles there were positive angles, right? 13 pi over 2 and 15 pi over 2. So which way should I be counting? Counterclockwise, right? If they were negatives, I'd be counting clockwise. So we'll start here. 0, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves, that's the beginning, 14 halves, 15 halves. So we're looking in quadrants 2 and 3. Feel okay? Again, all we did was count by halves there. Now I'm going to go and look at my problem here. Cosecant. Well, that's not sine, cosine, or tangent, so I want to see if there's a way to rewrite cosecant so it is sine, cosine, or tangent. If we remember back from chapter 2, cosecant is the same as the reciprocal of which one? Sine, cosine, or tangent? Sine is correct. Well, I'm going to write it as 1 over sine first, but you could write it as 1 over y. That wouldn't be wrong. So far, so good. Now, to get this to instead of be 1 over sine, I just want to make it regular sine. So what I can do is just flip both sides of the equation. Okay with that? And I know sine is just y. But if I go and I look at the y coordinates, none of them say 1 over the square root of 2. Right? If I go look at my unit circle, there's no y coordinate that has 1 over square root of 2. What's the matter? There's a radical in the denominator. We never write our fractions that way. What should we do to fix that? Yeah, we'll multiply the top and bottom by square root 2. And that I recognize, that is a unit circle coordinate, right? So I'm going to go to quadrants 2 and 3 and find the place where the y is negative root 2 over 2. So looking at the y's, nope, 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 yes. So 5 pi over 4. The only thing I have left to check now is to make sure that it lies on inside the interval that I need. 5 over 4 is 1 1/4, right? 13 over 2 is 6.5, and 15 over 2 is 7.5, right? Is 1 1/4 between 6.5 and 7.5. So we need to add 2 pi to that, right? So if I add 2 to 1 1/4, what do I get? 3 1/4. Is that between 6.5 and 7? Still too small, right? Well, let's add again. Now I have 5 1/4. Is that big enough? Okay, so we'll add again. Now I would have 7 1/4. That'll do. So we'll just make a common denominator. So 8 plus 8 plus 8 plus 5 is 29, and the denominator will be 4. Maura.
So I get like all of how you got that, but what's like the oh wait, never mind.
Okay. Does that feel okay? So this would be a normal problem outside of like, maybe you don't have to do that if it's just sine or cosine, right? Then it's just x or y is whatever. Kate.
So in the first one you did, you squared the you did, I don't know, you like squared.
I wrote that so you could see how I reduced that fraction.
Oh, okay.
That was why I did that, is so I could reduce that, because there was no x or y coordinate that had a 3 in it in any way, shape, or form.
Yeah.
I had square roots of 3 in places, but I didn't have just like a regular 3 in any x or y.
Okay.
So I'm like, well, that has to get out of there somehow. So what I noticed is if I rewrite it as square root 3 squared, I can reduce, and then I have a 1 and a square root of 3. I see 1's places, I see square root 3 places, so I feel like I'm making progress.
Okay.
Is that?
Yes.
Miriam.
For when you said y equals negative 1 over square root 2, that's only for like the cosecant problem, right? Like you want to put 1 over it if you were just doing like a normal like cosine or sine problem?
Correct. Sine is just y, cosine is just x.
And so what if it was like sine equals like negative square root 2? Like how?
That's an impossible answer for sine. Should we talk about worksheet 2?
Yes, please.
Okay.
And so,
Where should we start here? Number 1. Okay. So the first step, or the goal here when we're doing these problems, is I need to draw a picture. Because the picture is going to tell me how to write the equation to solve for theta. Without the picture, I can't do anything. Everybody okay with that? So I'm going to start by figuring out, just like we did before, what quadrant or quadrants I need to be looking at. So those are both positive values, pi over 2 and 3 pi over 2. So I'm going to be going counterclockwise with my counting. We always start at the positive x-axis, and so that's 0, pi over 2, that's the beginning, pi to 3 pi over 2. So we are concerned with quadrants 2 and 3. Now this says theta equals sine inverse of 0.11. That's the same thing as saying sine theta is equal to 0.11. Well, that's a positive value. So I'm going to now think about where sine can be positive. So we had an acronym for this. All silly turtles crawl. Each of these capital letters is an abbreviation for which trig function or functions are positive in that quadrant. A stands for all. All three, sine, cosine, and tangent, are positive in quadrant 1. S stands for sine. Sine is positive in quadrant 2. As a result, since they're not mentioned, we can assume cosine and tangent are negative in quadrant 2. T stands for tangent. In quadrant 3, tangent is positive. Since they're not mentioned, we can assume sine and cosine are negative. In quadrant 4, cosine is positive. Because they're not mentioned, we can assume sine and tangent are negative. So if we want to go and look at the places where sine is positive, we want A for all and S for sine. Everybody okay with that? So that's going to include quadrants 1 and 2. From this picture, I now know where my terminal side for theta lies. It must be in which quadrant? Quadrant 2. Why quadrant 2? It's the overlap of the two shadings, right? Is everybody okay? So let's draw our angle theta. So our initial side will always go on the positive x-axis. And the terminal side is going to go somewhere in quadrant 2. Does it matter where in quadrant 2 I put the terminal side? No, I always just draw mine in the middle so I have enough room to write around it. So that's my angle theta. Now I'm going to label the angle alpha. When I label my angle alpha, alpha is always the angle between the terminal side of my angle theta, that's the line we just drew in quadrant 2, and the part of the x-axis closest to that terminal side. So alpha needs to go in there. That completes my picture. Okay? What I'm going to do now is I'm going to write an equation based on what I see in this picture. So I'm going to compare theta, alpha, and then that end of the x-axis that also forms alpha. So if I compare theta to pi, does theta stop before it gets to pi or after it gets to pi? It stops before, which means that it is bigger or smaller than pi? Smaller, right? So theta plus something else is half to equal pi. How much further does theta have to go to get to pi? Alpha, right? That's what we labeled there. So far, so good. Now, to solve this equation for theta, what should I do to both sides to get theta by itself? Subtract alpha. This is some algebra 1 stuff right now, right? Just subtracting something from both sides to get an isolated variable. Yes? Sure. Okay. Now, how do we find alpha? Since this is a sine problem, alpha is going to be sine inverse, and it's always going to be the absolute value of whatever we were equal to. And now it's calculator time. Why don't you pull out your calculator and make sure that you get the same number that I'm about to get? You can borrow one.
That's fine. I still haven't done the calculator battery thing.
Oh, yeah.
I just kind of like forgot about it, you know. I kind of forgot, so.
What are you typing in?
Wait, so which one, what am I trying to find right
That's what we're trying to do, is solve for theta.
now?
Okay? If you got a negative number, you're probably in degree mode as opposed to radian mode. So there's a blue second button. Right next to that is the mode button. Press that. And then you should see an option that's either degree or radian. Make sure radian is highlighted by moving your cursor and pressing enter to highlight it. And then exit out and try it again. If you're in physics, you're going to have to be switching back and forth from degrees to radians like every day in class. Get used to doing this. If you loan your calculator to somebody in a physics class, you're going to have to be switching it back and forth frequently. If you borrowed a calculator from me, I suspect it's probably already in radian. So when I typed that into my calculator, I got 3.03 yada yada yada. This right here is what he's referring to more of.
Is it like the same thing for each problem, or
There's one little thing that could be different for one other wrinkle that can happen here, but the process is almost entirely the same. Okay?
Are you saying that could be like subtracting or adding the alpha?
Well, this equation can be different depending on where your terminal side is. But there's something else that we have to worry about here in just a minute. We'll look at an example in a second.
Okay, one more question.
Okay.
So, you know how like in green it's highlighted for sine?
Mhm.
Is that, like I get like how we found it, but isn't it just like the same for like, because like for number one it's just like inverse sine. So this is just always going to be what we're asking. You know what I'm saying?
No, it will not always be that.
Okay.
Because notice to find the theta, we didn't do sine inverse of 0.11 by itself. We did pi minus sine inverse of the absolute value of 0.11,
Okay.
right?
So the yellow is what?
The yellow is the equation that we wrote based on our picture. Oh, the yellow highlighter or the yellow marker? Okay, yellow highlighter is based on the interval. The blue is based on that this is sine is positive. So the overlap, the green, is where our terminal side needs to be. Mora.
Can you kind of put the highlighting really quick? I'm just a little. I know, I'm like,
So the yellow
yes,
is the highlighting between pi over 2
yes.
and 3 pi over 2. So if I count around, because they're positive, I'm going to be counting counterclockwise.
Yes.
Each quadrant is a half a pi.
Yes.
So 0, a half. That's the start of my interval. So everything after that should be shaded.
Okay.
Then I go to pi, and then 3 pi over 2, 1.5 pies.
Okay,
That's
yeah.
the end of my interval.
Mhm.
So that's why I've shaded quadrants 2 and 3.
Uh-huh.
The blue is being shaded because I see that sine theta is a positive number. Right? 0.11 is positive.
Yes.
Sine is positive in the first quadrant where all sine, cosine, and tangent are positive. And in quadrant 2, S, where sine itself is positive.
Okay, I get it now.
So I highlighted those two, and the green is the overlap.
So if sine was negative, would,
It would be down here.
okay, then you would TPC.
Okay. Let me show you something else about this type of problem. So there's no reason to ever get one of these wrong. They are all checkable, and it's a really easy check. So all I'm going to do is I'm going to plug theta into this equation and make sure I get 0.11. So I'm just going to do sine of my answer. If you use the answer key, like I've done here, you'll get exactly 0.11 back. If you round, you'll get about 0.11. So if you rounded whatever theta was, if you called it 3.03, you'll get about 0.11, but it won't be exact. So I feel good about that, but there's two parts to this check. The second part is I want to make sure that 3.03 is in between pi over 2 and 3 pi over 2. Well, 3.03 is a decimal. So to check this, I'm going to convert pi over 2 into a decimal. Oops. Wrong button. .03 is bigger than that. And then 3 pi over 2 into a decimal. It's smaller than that. Great. It's in between. I am now 100% sure that I have the correct answer. That was just me checking at the end, right? All of these are checkable. Most common mistake. Oops. Let's see what would have happened if instead of add or subtracting alpha, what if accidentally we had screwed up our equation? We said we should be adding it. What did we get? The exact number, but the wrong sign on it, right? That's a cue that, hey, we, like you messed something up, and the easiest place to check is either I have the wrong alpha, or I added alpha when I should have subtracted, or subtracted when I should have added, or in a problem like number 3, if you forgot to do the absolute value, and you did, instead of doing tan inverse of positive 5.25, if you did negative 5.25, same kind of thing could have happened. So if when you check, you get the wrong sign, one of two things happened. Either you forgot to do the absolute value when you did your alpha, or you added when you should have subtracted, or subtracted when you should have added. Is that okay? So just trying to help troubleshoot, like what to do if my answer doesn't check out, like where should I be looking for a problem? Everybody okay? Should we do another? Do you want me to pick one?
Is would tangent be different for gradient with this type as well? No? Okay.
Yep. I will pick.
Pi minus.
I'm going to pick 7. What do we notice is different about 7?
It's negative. Those.
Yeah, the theta's got to be a negative number, right? So let's do this again. So we're going to start by figuring out what 2 quadrants our answer has to lie in. So because our answer has to be negative, which way am I counting? Clockwise. So we go clockwise, -1/2, -1, -1.5. So we see that our answer has to be in between quadrants 1 and quadrants 2. Everybody okay there? So next, let's look at sine. So here I see sine theta should be -0.56. That's a negative number. Where is sine negative at? Quadrants 3 and 4, the T and the C. Because that means tangent only and cosine only. None of those are sine, so those are the places where they have to be negative. Now I'm going to start drawing in my angle. So I'll draw my initial side there at the positive x-axis and the terminal side in quadrant 2. And remember that we're going clockwise. So there's my theta. There's my alpha. And remember, again, alpha is always between the x-axis and the terminal side of our angle. It's always the acute angle formed between the x-axis and the terminal side of theta. Now what I want to do is write an equation that relates theta, alpha, and -pi together. So here's my question. Is theta happen before -pi or after -pi? Before. Does that mean theta is bigger or smaller than -pi? Think carefully. It's bigger because -pi is more negative than theta. So how much more negative is it? Alpha. But we shouldn't be adding, right? We should really be subtracting, because to make something more negative, oh my goodness, guys, I'm screwing this up. Sorry. It's theta minus alpha equals -pi. Right? Because I would take theta and I make it more negative by subtracting alpha, I should get to -pi. Right? Theta's like -1.5, or like -1/2. Pi's like -1. So I'd have to subtract another half from it to get to -1, right? So theta here should be -pi plus alpha. So that's what I'll be typing into my calculator. -pi plus sine inverse the absolute value of -0.56. Now, listen, folks. Do I really need my calculator to do an absolute value? Can we do that in our head? Yes. Don't forget to do it. I'm always going to write on my paper, but I'm never asking my calculator to do an absolute value for me. Because, yo, bro, I got this. I can make stuff positive. That's no problem.
Just for bullet, how do you put the answer like button into a calculator?
Oh, sure. If you press second and then the negative sign, that'll give you the ants key. So I get about negative 255. Which looks great because that sign of negative 255 gives me negative 0.56. And that negative 255 is smaller than negative 1/2 pi, and it's bigger than negative 3 pi over 2.
Okay, just for bullet.
Yes.
Okay, so is that theta equals negative pi plus percent?
Yes.
Okay, because I did that, if I didn't get your answer, but then I replugged it in and I got negative 0.56. So like, I don't know why I did like that. So I put in a positive pi on accident, and then I checked my answer, but I still got negative 0.56.
But is your answer between negative 3 pi over 2 and pi, or negative 1/2 pi over 2?
Yeah, I got 3.7.
Right, so that's not in between the two.
Yeah.
Right, so you could take your answer potentially and see if you can subtract 2 pi's to get it inside that range, but it's not guaranteed that that'll work.
Okay.
Lexi.
Do we have to round, like, you rounded there, do we have to round it to like the nearest hundreds or anything?
That's usually fine. Yeah, I'm happy with 2 decimal places. That's accurate enough for me to know that you did it right and not so stupid for you to have to write down like 10 decimal places. Because like that's just annoying, right?
On the quiz, do you want us, like, on top of checking it and putting it in our calculator, do you want us to like check if it's in the middle too?
You should, okay. So do I require you to check? No. Should you check? Yes. Are there 2 parts to the check? Yes. You have to check that it satisfies the equation and it's in the interval. Got to have both. Is that what you needed?
Yeah.
Okay. All right, folks. We ready to do this? I think it's go time. Iden.
Can I use the unit circle with all the notes or whatever?
I have a unit circle on your quiz. You can use the one that I give you.
Oh no, are you serious?
Yeah.
Well, I have so many notes up here.
Well, that's great. And I hope that you like continue to use them to work on your homeworks and stuff.
All silly turtles calls. All silly turtles calls. I don't remember my
Sure, whatever has a turtle that we
Why do you hate me? So many
All my actions is
Oh, that makes sense.
I
I think that he would survive, though, unfortunately.
It was one.
That class doesn't tell you what that's not
Sorry. He got me into my pants.
Dude, you walked in and it was big, bro.
Just write it down right
Nah,
now.
I know, I'm getting grabby.
Early's on time. Please. I'm already.
There's a difference between 1 minute warning and a real vote.
Or the pedal.
You don't know the difference.
So not all. I hope the week we come back at the latest.
Oh, wait.
Yeah, so there's 2 questions on the front, there's 2 questions on the back. The questions on the front should be done using the unit circle that is right on the front. The questions on the back should be done using your calculator. Make sure for the questions on the back, you're in radian mode, just like we talked about. If you're not in radian mode, that'll be difficult to get a correct answer. Okay. But they're just like the questions we just did. We started off, we did 2 question examples from the front page, and we did 2 questions from the back page. You guys can do this. I believe in you. Bless you. You're welcome.